In the group of non-zero rational numbers, under the binary operation, this given by A with binary operation B is equal AB by 3, the inverse of 9 is. To find inverse of this element 9, first we should know about what is the identity of this group. This group is of Q and this Q is non-zero, so exclude 0, and with this binary operation this forms group, and binary operation on two elements is defined as AB by 3. So we are seeking what is the identity element. So consider E is the identity element, so it will return A, and A is non-zero. So by the property of defining AE by 3 is equal to A, and this implies AE by 3 minus A is 0. This implies that take common because of these equation in rational numbers, so we can take common. Here this is no property of group is applying here. This is simple equation in rational numbers, so we can take common. A by 3 minus 1 is equal to 0, and this is non-zero, so E by 3 minus 1 is 0. This implies that E equal to 3, means identity element is 3. Now find inverse of 9. To find inverse of 9, consider this is an element of the group as a set of non-zero rational number, and this is binary operation. Its inverse is element A, so on operating these two elements it will return identity, and identity is nothing, 3. So 9 into A divided by 3 by the defining property on element with binary operation, this will return 3. It means that because of these are only rationals, so we can transpose and apply mathematical operation here. So A is 1. So inverse of 9 is 1, means option A is correct. What is the number of disjoint cycles of length greater than 1 in the permutation this? We have to find number of disjoint cycles of length 1. So this permutation is given, and 1 is going to 5, 5 is going to 3, 3 is going to 7, and 7 is going to 1. It means that cycle is 1, 5, 3, 7. This is closed cycle. Because of 1, 3, 5, 7 is used, so remember remaining one is element 2, 2 is on 2, so this is cycle of length 1. Now 3 is used, come to the point 4 or symbol 4, 4 is going to 6, 4 is going to 6, 6 is going to 4, means this is cycle of length 2. And asked about cycle of length greater than 1, so remove this point. So the cycle of length 1 we normally not write. It means that 1, 5, 3, 7, this is one cycle, and 4, 6 is another cycle. So there are two disjoint cycles. So option A is correct. In group theory, which one of the following statement is correct? Abelian groups may have non-abelian groups. If abelian group, then group and subgroup have the same binary operation. Also elements are coming from abelian group, so they will form commutative property. That's why non-abelian group doesn't exist. So subgroup of abelian group must be abelian. So statement first is correct, but by the word non-abelian, this statement becomes wrong. So first statement is wrong here. Now come to the second statement. Cyclic group may have non-cyclic subgroup. Cyclic group have subgroup. It means that identity element will be same and identity element generate whole subgroup. So it will be cyclic. So again this statement is wrong. Now come to the option C. Non-abelian groups may have abelian groups. This statement is correct because of we know that matrix multiplication is group but non-abelian group. But in matrix multiplication we are considering all, suppose Hermitian matrix. So it may be abelian or not, but you can consider this is matrix multiplication, and in general or precisely you can consider GLNR or restrict this GLN means up to order 2 means matrices of square matrices of order 2 and subgroup consider because of this have non-zero determinant, and consider subgroup as diagonal elements only have means only diagonal matrices. Then diagonal matrices product of two diagonal matrices will be same. It means it will become commutative property or become abelian subgroup of this. So non-abelian groups may have abelian group. This statement is true. Non-cyclic groups cannot have cyclic subgroup. Again this statement is wrong. Non-cyclic subgroups cannot have cyclic subgroup. It can have. So only statement C is correct. Number of group homomorphism from Z10 to Z. We are interested to find number of group homomorphism from Z10 to Z. In general, we have number of group homomorphism from Zn to Z1. This is direct concept, whatever n. So number of group homomorphism from Z10 to Z is only one. So option D is correct. But keep remember number of group homomorphism from Z to Zn, number of homomorphism will be n, and in this case one homomorphism will not exist, but onto homomorphism exist and equal to phi n. So remember these 2 points. So option D is correct for this question. As W1 is defined by this one, and elements of or constituents of W1 satisfying this property, and W2 is defined by this set, and elements of or constituents of element have this property. R subspace of R cube over R means field is real. Then dimension of W1 plus W2. Dimension of W1 plus W2 can be find using this result. Dimension of subspace sum can be find dimension of W1 plus dimension of W2 minus dimension of intersection W1 intersection with W2. So find dimension of W1. W constituents or elements constituent having this property x minus 2y plus z equal to 0 means x, y, z, these three are variable, so you are independent only on two variable to pick any value. Suppose you consider value of x is 1 and value of y is 2. Then using the above condition, x minus 2y plus z is equal to 0 means 1 minus 4 plus z is equal to 0 means value of z is depending on these two means value of z is nothing, 3 means if you pick any two entries then value of third one will depend on that means there is only two variable, so dimension of w1 is 2. Now dimension of W2 is 1. How? Elements or constituents of element having the property x equal to y equal to z means you are independent on single choice. Single choice means if you have the value of x, that means that value of y and z is same. So only you have one independent choice. So dimension of W2 is 1. Now come to the point, dimension of intersection of W1 with W2 as constituents of element having the property x minus 2y plus z equal to 0 and x equal to y equal to z, because if any element is in intersection, it means that it will satisfy the property of W1 as well as property of W2 means both property will satisfy. If x equal to y equal to z, so try to put here x minus 2x plus x equal to 0, x plus x, 2x minus 2x is 0, this condition is also true means if you have value of either x, y or z, then you are independent at a single choice. So dimension of intersection is also 1. Now put these value in the result as explained above. So dimension of W1 is 2 plus dimension of W2 is 1 and dimension of intersection is also 1. So 1 cancel out by 1 and dimension of W1 plus W2 is 2. So option B is correct. Let T be a linear transformation from a three-dimensional vector space V1 to a two-dimensional vector space V2. Then T can be both injective and surjective, neither injective nor surjective, injective but not surjective, surjective but not injective. Means we have to tell about 1 1 on 2 of this linear transformation as T is a linear transformation from V1 to V2 and dimension of this V1 is 3 and dimension of this V2 is 2. If we have or anyhow we can form matrix representation of this linear transformation, or for a linear transformation there exists a matrix representation with respect to basis, then matrix representation have the size 2 by 3 means dimension of codomain become the row and dimension of domain become the number of columns. So dimension of this matrix representation, suppose I find this matrix representation with respect to standard ordered basis and we cannot tell about standard ordered basis whenever V1 is not specified. This is in general three-dimensional. So consider this is a basis and this is a matrix representation. For onto it must have this matrix in each row pivot element. So maximum number of pivot element is 2 if exist. And for 1 1 each column have pivot. So there is 3 column, but maximum 2 pivot only will exist. So this linear transformation will not be 1 1. Or in other terms, you can consider there are more element here, so there are less element here. I'm not telling about which one set has more or less, but as dimension of this one is 3 and dimension of codomain is 2, it means here Li vector are 3, or Li and spanning elements are 3, and Li and spanning elements are 2. So some elements have particular image, means at least one element, at least two element will have the same image. So this linear transformation will not be 1 1. Now for onto, if we consider an element from range space, then it must have pre-image. It must have pre-image means this is a matrix representation. Suppose there is Y in this codomain, or an element B is in this codomain, then there exists X such that Ax equal to B. Means this system must have the solution, and this system must have the solution. Means there should be only one X. If there is more X exists here, it means that this system has many solution, more than one solution. It means there are two or more X that can satisfy this. It means that in terms of function, there are x1 and x2 existing such that f of x1 is y and f of x2 is y. In this case, a function will not be onto more. So this system have only unique solution whenever, sorry, not unique solution, this system will be onto whenever this matrix representation have same pivot element as number of rows. So this linear transformation can be surjective but not be injective. So option D is correct here. Consider the following linear transformation T from the vector space R square over R into the vector space R cube over R. Linear transformation T is sending order pair xy as this order pair or three tuple pair, then the rank and nullity of T are respectively. First number is showing rank and second number is showing nullity of this linear transformation. Whenever question for linear transformation is given to us, then always try to find matrix representation of this linear transformation or given linear transformation, because matrix representation is quick way to analyze rank, nullity and other respective eigenvalues if asked. So matrix representation beta 1 is the basis for domain and beta 2 is basis for codomain. So beta 1 will be 1 0 0 1. This is a standard order basis for R square over R. And beta 2 will be 1 0 0 0 1 0 0 0 1. This is a standard ordered basis for R cube over R. Means we are finding matrix representation of this linear transformation with respect to standard order basis. So image of 1 0 will be minus 1 3 times 1 plus 8 times 0, comma 9 times 1 minus 11 times 0. So image is minus 1 comma 3 comma 9, and this one can be written as minus 1 e1 plus 3 times e2 plus 9 times e3 if these are e1, e2 and this is e3. Means basis element for codomain can be easily called e1, e2, e3. So matrix representation or first column will be minus 1, 3, 9. Now find image of second element of this linear transformation. Basis element is 0, 1. So image of this element will be x, value of x will be 0. So minus 1 comma 8 comma minus 11. So this one can be written as minus 1 e1 plus 8 times e2 minus 11 times e3. So second column will be minus 1 8 minus 1. So we have matrix representation, and keep remember size of this matrix is 3 by 2, but you have calculated here, so anyone can tell the dimension of size of the matrix. So without finding the matrix representation, you can tell the size of the matrix representation. Size of matrix representation is basis for codomain or dimension of image set will be the number of rows, and dimension of or nullity will be the, or you can say basis dimension of domain will be the column of the matrix. So this matrix representation is 3 by 2. Now we are interesting to find rank represented by row symbol and nullity by this eta. So multiply first row by 3 and add second, and first multiply by 9 and then add. So minus 1 minus 1, first row is same, this, and value of second first element of second row is 0, multiply by 3 and add, so 5, multiply by 9 and add, and this will be 10. So you can multiply second row by 2 and then subtract, so this row will be 0. It means rank is 2. By rank nullity theorem, rank plus nullity is equal to number of columns. Number of column is 2. As rank is 2, so nullity will be 0. Otherwise this equation will not hold more. So rank is 2 and nullity is 0. So option C is correct. What is the dimension of the vector space formed by the solution of the system of the following equation? This is the equation. This is the system of equation x plus y plus z equals 0, x plus 2y is equal 0, y minus z is 0. So whenever a system is given to us, always try to write augmented matrix, because this is right hand side is 0, means this system is Ax equal to 0. It means all solution will be in null space. So solution that satisfy this system Ax equal to 0 will be in null space of A, means all solution of this system, and dimension of this vector space means this null space will form the vector space, and dimension of this one represented by eta and by rank nullity theorem, rank normally represented by row symbol, and this is by eta is equal to number of columns, and this is here 3. So write system 1 1 1 1 2 0 0 1 minus 1. So find rank of this matrix and then use this formula, rank nullity theorem. So apply elementary row operation here. So directly subtract R1 from R2. So this one will be 1 and this value is minus 1. 0 1 minus 1. Whenever you have two or rows either in same proportion or same, then cancel one row. So rank of this matrix, suppose this matrix is A, is 2. Rank is 2, so nullity is 1. So nullity is 1. So asked about nullity. What is nullity? Nullity is number of free variable. Here, as we can see, rank is 2 means that there are 2 pivot element. So only free variable is 1. So dimension of this null space is 1. So option C is correct. If the rank of a 6 by 6 matrix A is 5, then the rank of adjoint A is, means adjoint is taken 2 times, as you can see what is typed here. So rank of matrix A and size of this matrix A is 6 by 6 is 5. Then we know the result. If you don't know this result, then you maybe see this problem as a harder problem to find rank of this one. So rank of adjoint A can be easily find out if we know this result. If rank of A is n, then rank of adjoint A is n. If rank of A is 1 less, then rank is 1, and if rank of A is less than equal to n minus 2, then rank of adjoint A is 0. It means that in this question asked about rank of adjoint A. So we are seeking rank of this one. So consider this as a B, matrix B. It means that rank of adjoint B. And for this we have to find out rank of B. Rank of B. This is nothing but rank of what is B? B is adjoint A. Means find rank of adjoint A, because of rank of A is 5. 5 can be written as 6 minus 1. This is n minus 1. Property this is followed. So rank of this is n minus 1 type. So rank of this one will be 1. And this one is less than n minus 2. So rank of, because of rank of B is less than equal to n minus 2, so rank of this adjoint will be 0. So option D is correct. Try to understand how I calculated the rank. So option D is correct. If 1 minus 1 and 0 are eigenvalues of a 3 by 3 real matrix A, then A cube is equal to, as eigenvalues is given to you, then there is nothing in this question, as xi or eigenvalue normally represented by lambda, so lambda i's are 1 minus 1 0. So characteristic equation chx is equal to x minus 1, x plus 1 and x minus 0. So minus 0 have no importance, so normally write x. How to write characteristic equation? If lambda 1, lambda 2 and lambda 3 like this are eigenvalues, then you can write x minus lambda 1, x minus lambda 2 and so on up to distinct eigenvalues. So x square minus 1 and take x in front of this bracket, so x cube minus x. This is the characteristic equation or normally represented by fx. And we know by Cayley-Hamilton theorem, every matrix satisfy its characteristic equation. Satisfy its characteristic equation, it means that a cube minus a is equal to